All right, guys, welcome back. We are on day 2 of our coronavirus social distancing remote learning. Today we're working on rewriting expressions, specifically rational expressions and radical expressions. We're going to start with rational expressions. Now, when we talk about rational expressions, we're talking about expressions that are written as a ratio, as a fraction. So we have a fraction that involves an expression on the top as well as an expression on the bottom in the denominator. And so the first thing that we have to do when we're wanting to rewrite or simplify a rational expression, we want to attempt to factor the top and factor the bottom of the expression. So that'll be step 1. Now when we factor it, we may be factoring using x squared plus bx plus c methodology, the steps that you have. We may be factoring a special case, in this case a difference of squares. We may be factoring ax squared plus bx plus c. So there's a lot of different ways that we can go about factoring these, but that doesn't change the fact that if we want to rewrite a rational expression, we want to start by factoring. So up here we have x squared minus 9. X squared minus 9 is a difference of squares, meaning this is in the form a squared minus b squared. So when we have a squared minus b squared, we know that it factors into a plus b times a minus b. Every time. It's a difference of squares. So in this case, our a would be x, our a squared would be x squared, our b would be 9. So to figure out what a and b are, we would have to take the square root of both of those. This is just to identify what a and what b are as we find the difference of squares. So the square root of x squared is x. The square root of 9 is 3. And so what that brings us to is that a plus 3 times a, which is x, minus 3, which is b. So that's how we factor a difference of squares. And so our top, the x squared minus 9, can now be rewritten as x plus 3 times x minus 3. So now we factored the top. In order to factor the bottom, we're going to have to do our steps for x squared plus bx plus c. So in order to factor x squared plus 5x plus 6, since we don't have a number with the x squared, okay, or our number is 1, what we're going to do is we are going to make a factor tree of c. The reason we're allowed to do that is because there's not a number here with the x squared. So if we were to use the AC method where we multiply a times c, we would get 1 times 6. So we can go ahead and make a factor tree of c, 1 and 6, 2 and 3. We look at the sign of b, and that tells us that the larger of these two numbers is positive, because we know that these two numbers have to add together to make a positive number. We also know that if we look at the sign of c, these two numbers will multiply to make a positive 6. So if they multiply to make a positive 6, we know that they're going to have the same sign. We're going to have the little number be a positive and the big number be a positive, or we're going to have the little number be a negative and the big number be a negative. Negative, negative, positive, positive is the only way that we can actually multiply two numbers together to get a positive number. Since we already know the big number is positive, that eliminates the possibility of negative, negative, which gives us positive, positive. Now we want to do the math. And so positive 1 plus 6 is 7. Positive 2 plus 3 is 5. And we are looking for the pair of numbers that add together to make 5, which means we factor in to x plus 2 times x plus 3. Once we do this, we have factored the top and we have factored the bottom. And now, once we've got done that, we can attempt to cancel what we can. Important warning here. we need to identify the restrictions on the domain. Because once we cancel, that term is going to disappear and we're going to forget about it. However, in the original equation, it still exists. The restrictions that it caused are still there. So right now, we need to look at the denominator, and we know that in a rational expression, a denominator cannot be equal to 0 because we're not allowed to divide by 0. So what values would make our denominator 0? X cannot be -2 because -2 plus +2 is 0. X cannot be equal to -3. So these are our restrictions on the domain. X can be anything else we want. We can create decimals. We can create things like that. What we can't do, however, is divide by 0. So that excludes those two values from the domain. Now we can go ahead and cancel. Well, x plus 3 is on the top, x plus 3 is on the bottom, so when we divide those together, we get 1, which means they simply cancel out. And that will leave us in simplified form, x minus 3 over x plus 2, such that x is not -2 and x is not -3. And now we have rewritten this rational expression in a much more simple fashion. It's much easier to work with, it's much easier to do math with, it's much easier to solve equations with. And that's why we do this. That's why we simplify. Does everybody understand? Yes, Tucker.
Why isn't there letters in math?
Well, that's a great question. The reason is because we don't know what that number is. It could be anything. And so because we don't know what that number is, we have to give it a letter. That letter, called a variable, indicates that that could be any number, and it doesn't matter what number it is because we don't know yet. So we have to treat it as though it is just a number.
Daddy, why are you always this boring?
Well, on that note, if you have any questions, please remember, just comment below this video in the comment section and I'll be able to get back to you. I can either add a picture of a question worked out from your homework, or I can make a separate video showing how to work things out on the board. If you got any questions, just comment below. Now we'll move on to our next part of rewriting expressions.
Really?
All right, guys, now we have two rational expressions. And what we're going to do now is we are going to do step 2 of our process. So after we factor the top and the bottom, after we identify the restrictions on the domain, and after we see what will cancel out, meaning after we've simplified it as much as possible, if we have any math that has to be done, any operations, addition, subtraction, multiplication, and division, now we can go ahead and do these. Now, multiplication and division are probably our easiest too, because if we were to multiply right here, that's as simple as multiplying the top times the top, the bottom times the bottom. And when we do that, top times top, bottom times bottom, what we're left with is simply putting them together. X minus 3, x plus 2, x minus 3, all over x plus 2 times x minus 6. Again, at this point, we need to identify our restrictions on the domain. X can't be -2, x can't be +6, and now we cancel one more time. The x plus 2's will cancel, and we're with x minus 3 squared all over x minus 6. And now we've simplified our expression. So multiplication is pretty easy. Top times top, bottom times bottom, just put them together straight across. Division is not much more complicated. And so if we want to divide these expressions, what that gives us is keep, change, flip. So when we divide rational expressions, we keep the first side the same. So that's the keep. x minus 3 over x plus 2. We change our division into multiplication. And then we flip the last fraction. X minus 6 over x plus 2 times x minus 3. So keep, change, flip simply means division of a fraction is the same as multiplication by its reciprocal. Now, we're right back where we were with multiplication. We multiply the top times the top, and we get x minus 3 times x minus 6. Then we multiply the bottom times the bottom. X plus 2 times x plus 2 makes x plus 2 squared times x minus 3. X can't be negative 2, x can't be positive 3, and we cancel out. And we're left with x minus 6 over x plus 2 squared. So division is just one step added on to the multiplication. Now things get a little bit trickier when we are trying to add or subtract these. Now when we do addition and subtraction, it's the same process. And in order to do that, we will have to find a common denominator. We can't add apples to oranges. We have to change them into fruit. We have to have a common denominator to add or subtract fractions. So we will work with addition, and in order to add these, we got to find a common denominator. We can't add x plus 2's to x minus 6's. We just can't do it. So in order to find a common denominator, and this way always works, this is not a least common denominator. This is just a common denominator. What we do is we look at the denominator of the other fraction, x minus 6. We come over to this fraction and we multiply both the top and the bottom by x minus 6. And so what that will give us on this side is x minus 3 times x minus 6, because when we do multiplication, it's just top times top. And then bottom times bottom, x plus 2 times x minus 6. And so that gives us a new fraction on the left. And we're going to add that, and coming over here, once again, we are going to look at the denominator of the other fraction. And we're going to multiply both the top and the bottom by that denominator. So that will give us up top x plus 2 times x minus 3 times x plus 2 all over x plus 2 times x minus 6. Now, we have a common denominator, x plus 2 times x minus 6. This common denominator then allows us to actually add these fractions. Now, if we're subtracting, this is a key warning. If we're subtracting, remember, you have to subtract this entire quantity. So when you subtract it, you're subtracting the entire quantity. So that way, if you do simplify, don't miss a sign over there. So here we go. X minus 3 times x minus 6 plus x plus 2 times x minus 3 times x plus 2 all over x plus 2 times x minus 6. Now, why can't we cancel the x plus 2? Why can't we cancel the x minus 6? Well, it's because this isn't multiplication all the way across. We can only cancel things that are being multiplied by the entire quantity. Since this isn't multiplication, we can't cancel those. Even though one's on the top, one's on the bottom, we can't cancel it. So, at this point, we're done. We've simplified it. We're going to leave it in factored form. No problem. If you want to go ahead and use the distributive property or FOIL to FOIL them out, you can. Then you can combine like terms. That's another way. But this is a perfectly acceptable answer to me. as far as moving forward. So this is about as complicated as you're going to get when you're adding or subtracting fractions in Algebra 2. Most things are going to be much more simple than this. Again, as you work through the homework, if you have questions, go ahead and comment below. I'd be happy to answer them. Alright guys, so our last thing of the day. We are rewriting radical expressions now. Now radical expressions are expressions that involve a root. And so what we need to remember about those is that anytime we have a root, that's the same thing as a fractional power. And so if we take the cube root of x to the fourth, that root, the cube root, indicates that we are raising x to the fourth to a 1/3 power. X to the fourth is getting raised to a 1/3 power. So a cube root is a 1/3 power. A square root would be a 1/2 power. A fourth root would be a 1/4 power. And so what this amounts to, guys, is when we take this and raise it to a fractional power, we know from our properties of exponents that when you take a power to a power, you multiply. 4 times 1/3 gives us x to the 4/3 power. Now we can shortcut this if we understand that this number, the number inside, the power inside of the root, will be our numerator. The root, whether it's a square root, a cube root, a fourth root, etc., will be the denominator. So this makes it x to the 4/3 power. And that's our big idea here. Now, if we were to take something much more complicated, that's fine. What we want to do is we want to go ahead and we want to write these as simply as possible. So the cube root, 25, is just 5 squared. So we can rewrite it in its base format. X to the fourth, y to the third, z squared, and we're just going to do each of these individually because it's multiplication all the way across. So 5 squared, the cube root of that, the 2 is our numerator, and the root is our denominator. That makes it 5 to the 2/3 power. X to the fourth, the 4 is our numerator, and the 3 is our denominator. It becomes x to the 4/3 power. Y cubed. 3/3 is just 1, so that leaves us with just y. And then z squared, the 2 is our numerator, the 3 is our denominator, and we are done. Remember, if you guys have any questions, you can just comment below. Just comment below. I'll be able to answer your questions, and then we'll move on to day 3.
Right here. Yeah, they I want duck noises.
You want duck noises?
No, duck noises.